Hello there, welcome to MEP Booster. So in this lecture we'll discuss car parking ventilation system complete guide for design and installation. So let's start.
Now here you can see about car parking ventilation. So what is the main purpose of car parking ventilation? So remember here the car parking ventilation system is required to perform two functions. What are that? First, this car parking ventilation is used to prevent the buildup of carbon monoxide during the day-to-day operation of car park. So I think all of you know about carbon monoxide gas. This carbon monoxide is a colorless, odorless gas that can be harmful when inhaled in large amounts. Carbon monoxide is released when something is burned. The greatest sources of carbon monoxide to outdoor air are cars, trucks, and other vehicles or machinery that burn fossil fuels. Okay, and there are many causes of carbon monoxide poisoning from vehicles. Suppose operating a vehicle with a defective exhaust system, okay, and if you are driving a vehicle with the trunk lid or rear tailgate opens, and if you are driving a vehicle with holes in the car body, so there are many causes of carbon monoxide poisoning, okay, from a vehicle. Now the second function is what? Second is this car parking ventilation system we are using to provide smoke clearance in the event of fire. Because remember, as per NFPA, National Fire Protection Association, 75% of all fire that are caused by smoke inhalation, not by fire. Remember, okay? And this smoke is very harmful for human being. So smoke inhalation can cause several signs and symptoms that can range in severity, just like a cough, shortness of breath, headache, then noisy breathing, skin changes, eye damage. Because what happen here, smoke can irritate your eyes and cause redness. Okay, so there are many causes of smoke inhalation. So that is why in car parking ventilation system our main target is what? To prevent the buildup of carbon monoxide, and second, to provide smoke clearance in the event of a fire. Car parking ventilation may be classified into two types. First, we have a ductless system. So generally in ductless system we are not using a duct work, okay, to exhaust the smoke from the basement. Instead of that, here we are using jet fans, okay. So jet fan can, with the help of jet fan, we can exhaust or we can extract all the smoke from the basement easily, okay. Now remember, if you are using this system, jet fan, so remember, using a car park ventilation system with jet fans eliminates the need for bulky ductwork, okay. Not only does this result in saving on materials and space, but also in considerable saving in operational cost as the result of lower power consumption on the axial fan. By eliminating the ductwork in combination with a well designed control system. Okay, here with the help of this system, ductless system, you can save the material also, because we don't need duct, okay, ductwork here, and space also, you can save your space. Okay, so there are many advantages of ductless system. Now the second one, we have a ducted system. So in ducted system generally we have to install the duct work. See here, so in duct we have to install the grill, exhaust air grill. So what happen, when this area, this basement, here if suppose any case if there is a fire, okay, so what happens when smoke generate, so with the help of this exhaust air grill we exhaust all the smoke from the basement to the outside environment, okay. So in this way we are using this ducted system. But nowadays everyone eliminating this system, ducted system, and everyone are using this ductless system. Okay, because here you can save your material, and if you have not that much of space available in the basement, so you can easily install the ductless system on that time. Okay, a jet fan. So there are many types of jet fan available. Okay, axial jet fan, then centrifugal jet fan. So it is based on that how much amount of exhaust air you have to exhaust from the basement. So based on that we have to select the fan. Okay, that which type of fan you have to use. Now see about ductless ventilation system. So I have already explained you that in ductless ventilation system, instead of duct work we are using jet fan, and we have a different types of jet fan available in the market: jet vent axial fan, okay, or jet vent centrifugal fan. If you want to exhaust large amount of air from the basement, so you can you prefer centrifugal fan on that time, or then we have a axial jet fan also. So see what are the advantages of using this ductless ventilation system. So there are many advantages. Okay, here it is written first point that this ductless ventilation system required, it is a less expensive and easier to install than ducted system, especially in spaces where duct work is difficult to install. Generally what happen when you see now in basement, we have not that much of height available in the basement. So when you install the duct work, so on that time it is very complex to install the ductwork. Okay, so in that area you can just go through ductless ventilation system. Okay, because here we do not require that much of height, only we have to install the this jet fan. Okay, now the second advantage is this system provides localized ventilation, which can be more efficient as removing pollutants and allergens from specific area. Okay, now the third advantages of using this system, that can be more energy efficient. This system can be more energy efficient than ducted system, as they do not require the use of a central fan or blower here. Okay, now there are some disadvantages also. Okay, what are that? First it is written, this system may not provide adequate hold space ventilation system. Yeah, because here suppose we have installed one jet fan here, so we have to maintain some distance between jet fan to jet fan, how much distance we have to maintain and where we have to install. So for that we have a separate topic, don't worry about that, I will show you on that time. So yeah, it's okay that the disadvantages is what, may not provide adequate hold space ventilation, especially in a large parking space or home with multiple levels. Okay, second disadvantage is this system can be less effective at removing moisture and preventing mold growth, especially in humid climate. Third, this system may not be suitable for all types of pollutants or allergens, as they may not be able to filter out all particles or gases. So these are some advantages and disadvantages of ductless ventilation system. Now see about ducted ventilation system. So generally I have told you that in ducted ventilation system we have to install the duct. Okay, then in this duct only we have to install the grill, exhaust air grill. With the help of that grill you can exhaust all the smoke from the basement to the outside environment where you want to just extract that smoke, you can extract it. Okay, so what are the advantages and disadvantages of using this ducted system? So ducted system is also have some advantages. See here in that first advantages is what, this system provides whole space ventilation system. Why? Because you can see in this system we are taking duct routing to the whole space. See, and at every distance some space we have to maintain between grill placement, and we have a grill. So you can, with the help of this system, you can provide whole space ventilation, which can be more effective at improving indoor air quality and preventing moisture buildup and mold growth. So these are the advantages. Now the second benefits of using this system, that this system can be hidden behind walls or ceiling. Suppose if you have installed the ceiling, suppose in basement, generally in basement we do not have a ceiling, but suppose if ceiling is there, so is okay, uh, can be hidden behind wall or ceiling, making them a good choice for new construction or renovation. If there is a ceiling, so you can go through this ducted system only. Now the another benefit is what? This system can be more energy efficient than ductless system. Why? Because they can be designed to recover heat from the exhaust air, which can help to reduce heating cost in the winter season. Okay. Now the disadvantage is what? It is written required. This system requires a network of duct to be installed, which can be expensive and difficult to retrofit into existing home. Okay. Second disadvantage is what? This system can be noisy, especially if the ductwork is not insulated properly. Okay, so that is why this system is noisy. So these are the disadvantage. Now the last one, it is given that this system can be difficult to maintain and clean. Why? As the duct can become clogged with dust, debris and allergens over time. So that is why we cannot, it is very difficult to maintain and clean this system. Okay, because we have to open the ceiling, and then okay, we have opening, we have to give the opening, but it is very difficult. Okay, so these are the some advantages and disadvantages of using ducted ventilation system. Now see here how to design ducted ventilation system. What is the formula we are using, that how much amount of air we have to exhaust from the basement or from the car parking area. So for that we have a formula here. To find out the exhaust air CFM, formula is given that volume of space in meter cube into ACH, air changes per hour, divided by 1.7. So this is the formula to find out the exhaust air CFM, that how much amount of air we have to exhaust from the basement. So with the help of this formula you can easily calculate it. Okay, because we need the volume of space in meter cube, remember the unit also. So the length, width and height of that room we can easily get from architecture plan. Okay, then ACH is what? Air changes per hour. It means in 1 hour how many times we have to change the air to improve the indoor air quality. So for that we have an international standard. They will give you that how much time we have to just remove the air. Okay, we have to change the air in 1 hour, divide by 1.7. Now if you are exhausting air, so what happen? In the basement oxygen level will be down. So how to maintain the oxygen level? So for that, here it is written where ACH is air changes per hour. Now we have to supply the fresh air also in the basement to maintain the oxygen level or to improve the indoor air quality. So how much amount of fresh air we have to supply into the basement or into the car parking area? So it is given that 70 to 85% of exhaust air CFM is our fresh air CFM. Once you get the exhaust air CFM value, so 80 or 85% of that value we have to supply the fresh air. Okay, to improve the air quality also or to maintain the oxygen level. Now it is given that as per international standard, how much ACH we have to maintain, means how many times we have to change the air in 1 hour. So range is given 6 to 12 times. For normal mode you have to take ACH 6, for fire mode ACH 12 times. Okay, So this is about the for a ducted ventilation system designing details. Okay, calculation part. Now here see the duct size for ducted car parking ventilation system. Suppose if you want to install the duct, so you need, first of all you have to find out the duct size also. So how can you find out the size of that duct? So for that we have formula. If I talk about manually, if you want to do the calculation, if you want to find out the duct size manually, so you have to follow this continuity equation. Discharge flow rate Q is equal to A into V. A is area, V velocity. Okay, here it is written where Q is equal to air flow rate in CFM cubic feet per minute. It is the imperial unit of air flow rate, cubic feet per minute. A is area of space in square feet, and V is velocity in FPM, feet per minute. Now the question is that how much velocity we have to maintain, at what velocity we have to flow the air. So it is written for residential, if you are designing for residential building, suppose, so what velocity we have to maintain on that time? 700 to 900 fpm. Okay, and for commercial space, velocity we have to maintain 1000 to 1600 fpm, feet per minute, and for industrial area, velocity 1200 to 1800 fpm. So that much of velocity we have to maintain. So once you get the exhaust, suppose if you want to do the duct size for exhaust air, how many, suppose if you have calculated the exhaust air CFM Q value, so take that Q value and V value, this velocity you will get from this table. Okay, for residential is based on your that which type of building you are designing. Okay, that much of velocity you have to take, and finally you can calculate the area. Easily you get the size of the duct. Okay, so this is the manual method, but we have a software also, MacWay duct sizer software. Based on that software, with the help of that software, you can easily do the duct size. Okay, they can if you use the software, they will reduce your time also. Okay, now the next topic is filter box sizing. So first of all, tell me that why we are using filter box. What is the main purpose of using filter box? Remember, here you can see in this image, as I told you that if you have exhaust air from the basement, so we have to supply the fresh air also. So when you intake the fresh air na, so you cannot directly intake fresh air into the basement. Okay, because we know that the outside air which you have taken, so in that air we have a solid particles, unwanted particles are there. So if you supply directly air into the basement, so what happen? So that is why, to reduce that unwanted or to prevent that unwanted particles, so we have to install here first of all a filter box. You can see in this image, and inside this filter box we have a fan. So, and here this is our filter box. Okay, this is our filter. Three sides we have installed the filter, and in fourth side we have to install the duct. Okay, which is going, the air which is going inside the basement or inside the car parking area. Okay, first we have to take the fresh air from the environment and filter that air, then we have to supply that air into the basement area. Okay, now the question is here that how we can do the sizing of this filter box size. Okay, so for that here formula is there, Q is equal to AV, same formula, continuity equation, where Q is equal to fresh air CFM. Okay, Q is what? Fresh air CFM. You have to enter the value of that. And fresh air CFM, how you can calculate? I have told you, first of all we have to find out the exhaust air CFM, and once you get the exhaust air CFM, so we know that 70 to 85% of exhaust air CFM is our fresh air CFM, means that much of air we have to supply, 70 to 80%. Okay, so this Q is our fresh air in CFM, cubic feet per minute. A is total area of mesh. This mesh or filter both are similar. Okay, so the total area of mesh in square feet it is given, and velocity, what velocity we have to maintain? 250 to 350 fpm. Okay, you have to remember this point. So in this way we have to do the filter box sizing, but remember the velocity here 250 to 350 fpm. Okay, now here you can see that how to design the ducted car parking ventilation system, and how can we have to do the calculation for that. So here I have taken one question. So with the help of this question you can easily get that how we can design the ducted car parking ventilation system. So see what it is telling in question: a basement of length 40 feet, width 30 feet and height 15 feet. Find out exhaust air CFM, fresh air CFM, exhaust duct size, fresh air duct size and filter box sizing. This parameter we have to calculate. Okay, remember here exhaust air always we have to calculate in which unit? CFM, cubic feet per minute. Okay, because we are talking about in this calculation imperial unit. Okay, so you have to use feet. Okay, so see here in solution what detail is given in this question. So we know that to find out the exhaust air CFM, that we have a formula. If you remember, I have already discussed about that volume of space in meter cube into ACH, air changes per hour, divide by 1.7. Okay, so in that first of all we need volume of space, and if you remember here in question basement length, width, height is given, but remember the height, width and length is given in which unit? In question feet. So first of all we have to convert that feet in meter, then only you can put that value in this volume of space. So given that length, how much it is given? 40 feet. So first of all we have to convert that feet into meter na? Because here we need volume of space in meter cube. So how to convert? We have to multiply by 0.3, so you get the value 12 meter. Now you can see width in question is given 30 feet. So to convert that feet in meter, again we have to multiply by 0.3, so you get 9 meter, and height how much? 4.5 meter. Now how to calculate the volume? We know that volume of space is what? Length into width into height. So when you do the calculation na, you get 486 meter cube volume. Okay, once you get the volume, so we know that for normal mode how much we have to maintain the ACH value. If you remember in previous session we have discussed about that. For normal mode always we have to take ACH 6. It means what? ACH is air changes per hour. It means in 1 hour we have to change the air 6 times. 6 times we have to change the air. Okay, to improve our indoor air quality. Okay, so formula is what now? Exhaust air CFM is equal to volume of space in meter cube into ACH divided by 1.7, and volume of space we have calculated, and for normal mode ACH we have to take 6. So you have to put all the value in this question. So finally when you put volume of space, how much we get? 486, and into 6 divided by 1.7. So exhaust air CFM we get 1715.3. okay, in CFM, cubic feet per minute. Now we have done exhaust air CFM, we have calculated that. Now I want to calculate the fresh air CFM. So how we can calculate the fresh air CFM? I have already told you in formula. To find out the fresh air CFM we have a formula that 70 to 85% of exhaust air CFM is our fresh air CFM. So you have to take between this range. So suppose I have taken 80%. So we have calculated exhaust air CFM how much? You can see in this image how much we get exhaust air CFM 1715.3. So take as a 80% of this exhaust air as a fresh air. So how can we take? Just see here. So to find out the fresh air CFM, see, I have taken the value of exhaust air CFM 1715.3 into 0.8, 80% I have taken. Okay, so you get the value how much fresh air CFM 1372.24. It means that much amount of fresh air we have to supply into the basement. Okay, so we have done both but remember this calculation which you have calculated na, exhaust air CFM and fresh air CFM, is for normal mode. Okay, suppose if there is a fire mode, so for fire mode ACH value how much we have to take? 12. Means in 1 hour we have to change 12 times air. Okay, now same formula we have to use to find out the exhaust air CFM, volume of space in meter cube into ACH divided by 1.7. Volume of space we have already calculated 486, into ACH value you have to take 12 divided by 1.7. So finally you will get the exhaust air CFM how much? 3430.6. And remember your one point, always remember everyone, while doing the duct size always we have to take what, because duct size is totally depend on if you are doing the exhaust air duct size, so we have to take that exhaust air CFM Q value is that much. So always duct size is always depend on fire mode. Okay, always we have to do the duct size for fire mode only. Okay, so that is why suppose if you are calculating the duct size, so we have to prefer what, suppose if you are doing the exhaust air duct size, so we have to take Q value, exhaust air flow rate value how much? 3430.3, 30.6. Now in case of fire mode, remember, okay, in case of normal mode we have to supply fresh air, but remember in case of fire mode, in car parking ventilation system, in case of fire mode we don't need to supply fresh air. Why? Because you know that, I think, for fire we need three parameter. What are that parameter? Oxygen, heat, fuel. If one of them are not present, fire will not occur. Okay, so if in suppose if there is a fire in basement and you are supplying oxygen, because if you supply the fresh air, it means you are supplying oxygen into the basement, it means your fire frequency, fire will increase. Okay, so that is why remember for fire mode we do not have to supply the fresh air. Okay, next thing, note, it is written here, in fire mode do not need give fresh air, do not need to give fresh air. Okay, now how to do the exhaust air duct size? See everyone, so for that I have told you we have to use what formula? Q is equal to AV, continuity equation. Here Q is what? Exhaust air CFM, and we have calculated how much exhaust air CFM? 30.6. And I have told you that always duct size we have to do always for fire mode only. Okay, so here for commercial, okay, Q value we know that 3430.6, but how much velocity we have to maintain? So velocity is totally depend on what, for which building you are designing. It is a public residential building, commercial or industrial. So suppose I am assuming I have a basement commercial building. Okay, so for commercial building what velocity you have to maintain? You have to take 1000 to 1600 fpm. Between this range you have to take the velocity. Okay, now see Q value, we have to take 3430.6 CFM for fire mode only. Now put this two value, you will get the area. You can see here how we can get the area. Area is equal to Q upon V. Q value 3430.6, which you have calculated for fire mode, and velocity, suppose I have taken maximum velocity 1600 fpm. Okay, so we will get the area 2.14 square feet. So once we get the area, so you can easily size the duct. You know that we have a different shape of duct, rectangular, circular, square. So what type of duct you need, it is based on your requirement. Okay, So suppose if you find out, if you are doing the duct size for rectangular duct, how to find out the size of that duct? See everyone, so this is my rectangular duct. Okay, so how it's look like this. Here we have a length of this duct is L, and this is a width of this duct. Okay, and here we have a height of that duct. Okay, width, height, and this is a length. So our main target is what? We are doing the, we are finding out the size of duct na, this width and height. What is the width and height of this duct? So this is our main target. So area we have calculated, if you remember, 2.14 square feet. Now here you have to tell me that what is the area of rectangle. It is simple, width into height. Okay, so area of rectangle is what? Width into height. So here you have to write down width into height is equal to 2.14. Now what you have to do? In case of rectangular duct, here we have to satisfy this ratio. Width by height is always greater than equal to 1 and always less than equal to 4. As per SMACNA, we have to satisfy this ratio. Okay, it means suppose if you have taken your width value is coming something and height is coming something, when you do the ratio na, so your value will be between this 1 to 4. Okay, remember we have to satisfy, but this condition only for rectangular duct. Okay, as per SMACNA we have to satisfy this ratio. So here height you have to assume, how much height you have to assume. And suppose if you are doing the live project, so on that time they will give you the height, that how much height you have to take for your services, for HVAC services. Okay, so they will give you on that time, but here during calculation, here height you have to assume. And remember, height you have to take as per that. If you do the, if you calculate the ratio na, you will get the value between this, it will be greater or equal to 1 or less than equal to 4. So what height I have to assume? So see, suppose I have assuming let height of duct is 1.2. so if I have taken height 1.2, so we have to this height value we have to place in this equation, which this equation we have calculated now, width into height. So once you put the value of this height in this equation, so you will get the width also. So finally when you put the height in this equation na, so you will get the width. See, 2.14 divide by, because height will come this bottom side, so divide by 1.2. finally you will get the width of duct, how much? 1.78 feet. So convert this feet in mm. So how to convert? We have a conversion formula. 1 feet is equal to how many mm? 304.8 mm. Okay, so that is why here what I have done, width we get 1.78 feet. If you multiply this this product 304.8, so you will get the value in mm. So here when I multiply, I will get 542.54. So it is around 550 mm. And similarly I have done for height. Okay, so when we convert the height in feet in mm, so you will get the how much height? 350. Now what you have to do, just take the ratio width divide by h. When you take the ratio na, the value is coming between this range 1 to 4. It means your condition is satisfied, you can take this value, it is a correct. Okay, so finally we have calculated the exhaust at duct size, how much? 550 width and 350 height. Okay, in this way we have to do the calculation for rectangular duct. Now suppose if you are using round duct, so for round duct what we have to do? So for round duct we have to calculate the diameter of duct. So how to calculate the diameter? Simple. You know that the area we have calculated 2.14 square feet. Area of circle is what? Pi by 4 d square. Simple. Okay, so we need to find out the diameter. So when you simplify na, you will get the diameter around 1.65 feet. and to convert feet in millimeter you have to multiply by this factor 304.8, so you get the value around 500 mm. Okay, so in this way we have to, if you are selected round duct, so in this way we have to calculate the diameter of that duct. Now suppose if you have taken, if you are doing the duct sizing for square duct, if your duct shape is square, so for that how you can calculate the size of that duct? Simple. Here you can see, here we have one image, and in that image I have taken a square duct. The length of that duct I have taken is capital L, and side of that duct is what? For square we have same side, all sides are same, so small a I have taken. So area, how much we have calculated? 2.14 square feet. Okay, area of square is what? A square. Simple. If side you have taken small a, so area of square duct a square. So finally you will get the small a value 450 mm. Okay, so it means what? Exhaust air duct size is how much? We have calculated for square duct 450 mm by 450 mm. Okay, so in this way we have to find out the exhaust air CFM. Based which type of shape you have selected, based on that shape you will get the exhaust air duct size. Okay, now we have to calculate the fresh air duct. We have to do the fresh air duct size. So for fresh air duct size, remember fresh air only we have to supply for normal mode. Okay, and we have calculated how much, I will show you. So we have to use same formula, Q is equal to AB, which we have used in exhaust air duct sizing. Here for commercial, what velocity we have to maintain? 1000 to 1600 fpm. Suppose I have taken 1600 fpm. Okay, because we are designing for commercial building, so velocity I have taken 1600 fpm. Okay, and Q value we have calculated in normal mode, how much? Fresh air 1372.24 cfm. So to find out the area, you can easily get the area. So suppose first of all I am doing the sizing for rectangular duct. So if it is a rectangular duct, so we know that, you can see in this image here we have a width of this duct, height and length of that duct. So how to calculate the area? Same, we have to use this formula. So you will get the area. Area how much? 0.86 square feet. Now tell me, for rectangular, what is the area of rectangular? Width into height. Simple, you have to put that value, width into height. Now then remember, in case of rectangular duct we have to satisfy that ratio. What ratio? We have one condition as per spec na, we have to satisfy this ratio. Width upon height is always greater and equal to 1 or less than equal to 4. 1:4 ratio, this is the aspect ratio. Okay, but we have to satisfy this aspect ratio. So see, so here we have to assume the height of that duct, so you will get the finally. So suppose here I have assuming height of duct is 0.8 feet. So put this value in that equation which we have calculated now, width into h into area. When you put, you will get the width of duct 1.07 feet. Now convert this feet into mm. So when you convert now, you will get width of duct 350 mm and height how much? 250 mm. Then just divide both of them, 350 divided by 250, so you will get a value around 1 point something. It means you are under that ratio now, 1:4 ratio. So condition is satisfied. It means the value which we have selected, height which we have taken, it is right. So width or height of this duct is given here. Okay, so in this way you have to do the calculation. Same way finally we get how much exhaust air duct size for fresh air. So not exhaust air here, remember here we get the fresh air duct size 350 into 250 mm. Okay, now note here, similar we have to do for round duct and square duct size. Okay, which we have done now for exhaust air, same way we have to do for round and square duct size. So in this way we have to find out the exhaust air duct size, fresh air duct size manually. Okay, And we have a software also, MacWay Duct Sizer software. With the help of that software also, you will do the duct sizing to reduce your time. Now the next last, what we have to find out, we have to find out the filter box sizing. And I have already told you why we are using filter box. Because suppose if you are designing for normal mode, we have to give the fresh air also into the basement. So fresh air we are taking from outside, so directly you cannot take that air and supply to the basement. We have to install the filter box first. We have to filter that air, then only you will supply the air to the basement. Okay, so how to do the size, how to calculate the sizing of that filter box? So for that, same formula, Q is equal to AV continuity equation we have to use, but here remember the velocity is different. What velocity we have to take? 250 by to 350 fpm. Okay, that much of velocity we have to take. So here I have taken 300 fpm velocity, and Q value, fresh air CFM we have calculated na 1372.24. Divide both of them, so finally you will get the area of that mesh. How much? 4.57. Okay, so area of filter we get 4.57 square feet. Now what we have to do, you can see here one image is there. This is a filter box. So suppose in filters box generally we have three sides, means air will intake from three side. This from front side. Okay, yeah, this is our filter. So air will intake from front side, then here through this side and through this side. Then the side which is back side, we have to connect the duct, okay, which is going into the basement. So air will intake from three side. So here you can see, so air intake from three sides. So can you tell me the each mesh or each filter area is how much? So if the total area we have calculated 4.57 square feet, total area of that filter mesh we have calculated 4.57. Now air intake from three sides, so therefore each mesh area or each filter area we get 1.52 square feet, each filter area. And remember here the mesh or the filter which we have to install in the filter box, here how much this gap we have to maintain? 1 inch. Okay, it is the standard gap space we have to maintain. Okay, 1 inch we have to maintain the gap during the placement of filter into the filter box. Okay, now here we have calculated each mesh area 1.52 square feet. Okay, now what you have to do, once you will get the each mesh area, so suppose if suppose my mesh or my filter, mesh or filter both are same. For a square mesh we know that if side I have taken for mesh, suppose my mesh side is small a, so for a square what is the area of mesh? A square is equal to 1.52. so finally you will get the side of that square mesh 400 mm. Okay, so this is the size of your filter or your mesh, 400 mm width, 400 mm height, because all sides are equal. Now okay, we get the mesh size. Now we have to calculate the filter box size. So to calculate the filter box size, see, if once you will get the mesh size 400 mm, I have already told you that what space we have to maintain during the placement of mesh into the filter box. 1 inch standard gap for both sides. So you have to add both 400 plus 25 plus 25, so you will get 450 mm length, 450 mm width, 450 mm height of that filter box. Okay, so in this way we have to do the calculation. Okay, I hope all of you understood about this calculation. Now see about ductless ventilation system. Now tell me, what do you understand by ductless car parking ventilation system? So simple. In this system we are not using duct work to supply or to exhaust air from the basement. Here we are using a jet fan. Okay, with the help of that jet fan we are going to extract all the exhaust air from the basement. Okay, so you can see there are different types of fan we are using. So see the types of fan what we are using in ductless system. So first of all, we have a jet vent axial fans, or you can say impulse fan. In this image, I have shown you the jet vent axial fan. Okay, so here some standard size of fan available. Okay, suppose if you are using, if you need 32 Newton thrust fan, so the diameter of that fan is given 315 mm. And how much area this fan can cover? 32 Newton thrust fan can cover 400 square meter area. Okay, now if you are using this axial fan of 50 Newton thrust, so it will cover how much area? 500 square meter area, and the diameter of that fan is 400 mm. Okay, so this is about jet vent axial fan or impulse fan. Now the another fan is what? Jet vent centrifugal fan or induction fan. You can see in this image here, we are in this figure, centrifugal fan is shown. Okay, it means you can suck air from this part, from bottom part, and then discharge it through this part. Means suction and discharge line both are perpendicular to each other in centrifugal fan. Okay, and remember, this fan generally we are using for if you want to discharge high amount of airflow rate, so you have to use this centrifugal fan. You can see, suppose if you are using 50 Newton thrust fan, centrifugal fan, so one fan can cover how much area? 500 square meter area. And if you have used an 100 Newton thrust fan, so one fan can cover how much area? 1000 square meter area, and the diameter is also given 640 mm. Okay, so generally jet vent centrifugal fan we are using for discharging, for exhausting high amount of airflow. Okay, so this is about the type of fan. Now here one image is there. Here you can see we have installed in each and every floor jet vent axial fan. See, so what happened? Suppose this is a basement, three basement 1 2 3 4 basement is there. Okay, and suppose in case of fire, when smoke will smoke is there into the basement, and we have to exhaust that smoke. So this jet vent axial fan is start, and see, this fan suck that exhaust and supply it to the another jet vent fan. Okay, then this fan exhaust the air of, it can cover 400. Suppose if you are using 50 Newton thrust fan, so it can cover 400 or 500 square meter area. So it will just cover that area and discharge that air to another jet vent axial fan. Then finally here we have a open to sky. Okay, one space is there, it is open up to sky level. Here we have installed the exhaust fan. Okay, and here we have a exhaust air lower. This exhaust air will go inside this lower, through this lower, and this exhaust fan will suck that all exhaust air and supply it to the environment. Okay, then same way if you want to supply the fresh air, so see, we are supplying fresh air with the help of this duct open to sky, you can say. Okay, here we have installed the fresh air fan, and this fresh air fan always we have to install into the filter box. Okay, I have already told you. So that air we have taken from outside air, and that will suck from this fan, and forcefully we are supplying that fresh air to each and every basement. Okay, why we are supplying this fresh air? To maintain the indoor air quality, or to what? To maintain the oxygen level in the basement. Okay, with the help of fresh air lower. In this way we have to install all this system. Now here you can see the plan view of ductless system. This is our exhaust supply air fan. Here we have an exhaust air fan. VSD is also there, variable speed drive. VSD is what is the function of VSD? Or VSD or VFD, both are similar. So variable speed drive, it is used to regulate the speed of a fan. Okay, So here we have a exhaust fan, and here we have a supply air fan, means fresh air fan to supply the air into the basement, and exhaust air, we are using this fan to exhaust the air from the basement. Okay, and see here we have installed the axial fan, or whatever, if you are using centrifugal fan. So see, some distance we have maintained from fan to fan. How much? Somewhere we have used 30-meter distance. Okay, and you can see here we have installed the CO. CO is what? Carbon sensor. So why we are installing this CO, carbon monoxide or carbon sensor? It is used to sense the carbon in the area up to some level. If the level exceed, it will give a command to a jet fan to open. Okay, then you can see here we have a fan. Okay, so in this way we have to use this. And remember, for selecting position and angle of fan, we have to submit a report to CFD people. Okay, CFD means what? Computational fluid dynamics. So suppose, okay, we have installed the fan, but what is the position and angle of that fan? So remember, for selecting position and angle of fans, we have to submit a report to CFD people. They will do their work and hand over us the graph, okay, which shows the position and angle of a fan. And for this process, 1 week is compulsory. Okay, so in this way this ductless system work. Now see the sequence of operation. Here in first column, ppm of carbon monoxide, part per million of carbon monoxide is given, and then exhaust air fan, fresh air fan, jet fan, all this parameter is given. Suppose if your carbon monoxide is less than 15 ppm in the basement, suppose, so exhaust air fan will run with how much speed? 50% speed they will run. Okay, fresh air fan also we have to run with 50% speed, because this is the normal mode na? So both fan are run 50%. But in that case, jet fan, we don't need to run the jet fan. Okay, they can cover that. Fresh air fan and exhaust air fan can exhaust the that much amount of air from the basement. But if your carbon monoxide level in the basement is between 15 to 30 ppm, so on that time fresh air fan is running with 50% speed, or exhaust air fan also running with 50% speed. Here if your level of carbon monoxide is between 15 to 30, then we have to run the jet fan also with low speed. Okay, and who will just you can say, who will control the speed of this all fan? We have a VFD, okay, variable frequency drive, and we are using VFD for what purpose? To regulate the speed of a fan. You can use it. Okay, so we have to run jet fan with low speed. Suppose if your carbon monoxide level in the basement is more than 30 ppm, so on that time exhaust air fan will run with 100% speed, and fresh air fan is also running with 100% speed, and jet fan we have to run with low speed. It can cover it, it can exhaust it easily. But if it is a fire mode, if there is a fire in your basement, so on that time we have to run the exhaust air fan with 100% speed. But remember, here we do not use the fresh air fan. Fresh air fan will not running, will be off. Okay, because in case of fire we do not need to supply fresh air into the basement. Okay, if you supply the fresh air, it means you are supplying oxygen into the basement. So we know that for fire we need three parameter: oxygen, heat and fuel. If you provide the oxygen, it means your fire increase. Okay, so that is why we don't need to supply the fresh air in that case, fire mode. Okay, and jet fan we have to run with high speed on that time. Okay, so this is about the sequence of operation of car parking ventilation system. Now here you can see the main components of ductless system. What are that? First of all, we have an axial fan, then we have a jet fan, and we have a different types of jet fan. I have told you axial jet fan, and sometime we have to install the centrifugal jet fan. So it is based on that how much amount of air you have to exhaust from the basement. Okay, if it is a high capacity of air we have to exhaust from the basement, so you have to prefer centrifugal fan on that time. Otherwise axial jet fan can cover that. Okay, then we have a sensor, carbon sensor. Why we are using it? Is used to sense the carbon in the area up to some level. Okay, if the level exceed, it will give a command to a jet fan to open. Okay, that is why we have to install the sensor also. Now here we have a control panel. Okay, then communication cabling, and finally CFD analysis. CFD stands for computational fluid dynamics. And why we are doing the CFD analysis? Remember, for selecting position and angle of fan, we have to submit a report to CFD people. They will do their work and hand over us the graph which shows the position and angle of a fan. And for this process they need 1 week. Okay, 1 week is compulsory. So this is all about this component of ductless system. Now the next topic is installation detail of exhaust fan. So you can see here one image is there for installation of exhaust fan. See how this fan is installed here, what distance we have to maintain from finished floor level to this installation of this fan. Okay, how, see how we can hang this exhaust fan. So for that, here we have one image. You can see this is our basement 1 and basement 2. Okay, and we have installed this exhaust fan here. Okay, see what distance we have to maintain. This is a section view of exhaust fan. Okay, see 1.2 meter distance we have to maintain from this wall up to here. Okay, then see we have to hang this exhaust fan, and minimum, see what distance we have to maintain from finished floor level to this fan, 543 mm. And you can see here we have a different component inside this fan. This is our fan. Okay, now here we have a motorized damper. Why we are using this damper? To regulate the speed of our fan. Okay, then after that we have a backdraft damper. So this backdraft damper, the function of this backdraft dampers, this damper allow air to efficiently flow through exhaust duct to the outside, and this damper prevent the unwanted flow of air into a basement when the exhaust fans are off. Okay, that is why we have installed the backdraft damper here. After backdraft damper, see we have installed here FD, fire damper. So this damper prevent the spread of fire, which helps to stop a fire from spreading. Okay, that is why we have to install the fire damper here. Okay, so this is the installation detail of exhaust fan. Now here one more image is there. This is the front view of exhaust fan. See how it's look. All detail is given. See from wall to this fan, how much distance we have to maintain, at what height we have to install this fan from finished floor level, 440 mm. Then see hanger detail is also given. Okay, now see the placement of jet fan, how you can place this jet fan. So suppose here this is my axial jet fan. Okay, so a common size axial jet fan creates 25 Newton thrust. Okay, a common size can creates 25 Newton thrust. So we know that 25 Newton thrust jet fan could cover around 300 square meter area. Okay, if you have selected a 25 Newton thrust jet fan, so remember that 25 Newton thrust jet fan can cover how much area? 300 square meter area. Okay, and if you have selected 32 Newton thrust jet fan, so that fan can cover around 400 square meter area. Remember all this point. Okay, this is very important during the placement of jet fan. Now if you have selected 50 Newton thrust jet fan, so they could cover around 500 square meter area. One jet fan can cover 500 square meter area. Now the distance between two jet fan, how much we have to maintain? 25 meter. Okay, from one jet fan to second jet fan, how much distance we have to maintain? 25 Newton. Okay, now see here, take one example. Suppose here I have a basement. Length of basement is given 100 meter and width is 60 meter. And here I want to show you that how many number of jet fan we need in this basement. So first of all, we have to calculate the area of this basement. So basement area is how much? 100 into 60, 6000 square meter. Okay. Now suppose I have selected 25 Newton thrust jet fan. Okay. And we know that 1 fan 25 Newton thrust jet fan can cover how much area? 300 square meter area. One fan can cover 300 square meter area, and total area of basement is 6000 square meter. So suppose here I have selected 25 Newton thrust jet fan, and this fan can cover 300 square meter area. Now how many number of jet fan we need in this 6000 square meter area? So we have to divide first of all. Okay, you can see 6000 divided by 300 square meter. 20 nose jet fan will install. So in this area, how many number of jet fan we have to install? 20 number of jet fan. Now okay, 20 number of jet fan we need. So suppose here I have done, see, 1 2 3 4 5 6 7 8 9 10 10 10 20. Okay, you have to install in horizontal, 5 in row and 4 fan in column. It means it can throw 20 meter here and it can cover 15 meter here in this vertical direction, one fan. Okay, so see how we can install it. In this way we have to install the jet fan. Okay, and what distance we have to maintain from one fan to second fan? 25 meter. Okay, based on your thrust, means how many Newton of thrust you have selected. If you have selected 32 Newton thrust fans, they can cover 400 square meter area. If you have selected 50 Newton thrust fan, they can cover 500 square meter area. Okay, so this is about the placement of jet fan. Now here I have taken one manufacturer catalog for jet fan. See, this is our catalog. You can see here in first column fan size is given. Okay, then airflow in CFM or in bracket meter cube per hour, then thrust, throw, power, motor size, motor speed or noise level is also given. Okay, now see how can you get the all detail. Suppose if you have selected, I have told you, suppose if you have selected your total, you have calculated that how much amount of air we have to exhaust from the basement. How we can get that air? We have a formula: exhaust air CFM is equal to volume of space in meter cube into ACS divided by 1.7. Okay, with the help of this formula you will get the exhaust air CFM. Once you will get the exhaust air flow rate or exhaust air CFM, so you can see here in second column, here exhaust air CFM is given 2640, 2220, 2250 CFM, 4070 CFM. Based on this CFM value, you will get the fan size, how many Newton of thrust you have to maintain. Here you will get the detail of that. Okay, then that fan, how much throw that fan, so it is also given in feet and in meter also. See, throw of that fan. Suppose your flow rate you have calculated and you get around 2500 CFM, so we have to follow this first row. So for that, see, fan size is given and thrust how much? 24.9. it means around 25 Newton thrust fan we have to select. Okay, then this fan can throw how much long? 25.9 meter it can throw the air. Okay, then power 0.94 kilowatt or 1.26 bhp. Motor size is also given 1.5 HP, motor speed, and see 71 at the rate of 550. Noise level is also given. Here see the section view of jet fan is given. Okay, junction box, silencer we are using to reduce the noise level. Okay, then here we have installed the fan. So based on your airflow rate, you will get the fan size, thrust, flow, power, motor size as per manufacturer catalog. Okay, here I have taken one of the catalog here for jet fan. So based on your that which manufacturer you are following, on based on that manufacturer you will get the catalog and you can select your fan. Okay.
So this is all about the complete car parking ventilation system design. Hope all of you enjoy the session. See you in next one.